So this is the last question they look at in the tutorial. It involves finding the equation of a hyperplane. And it's not so bad once you know how to extract the right information. So it's given that we have a bunch of feature vectors, or basically samples. We have samples 1 through 10, and they each have feature values x1 and x2. So we can represent this in like a two-dimensional grid. Our first task is that given that omega naught equals 1, we have to find the discriminant function for the initially proposed boundary and plot the hyperplane H. So first thing we know is that W naught is equal to 1. That's nice to know. The general form of a discriminant function looks like this. So this x here it's like a vector. Okay, so it's got an x1 and an x2 component. So if you had a two-dimensional graph, the horizontal axis you can call x1 and the vertical one x2. And some point here, this is your vector x, and it's got an x1 coordinate and an x2 coordinate. Okay, so it can be a little confusing if, because they use x for everything, and we're used to saying x is horizontal and y is vertical. But this is just 2D space, and they use this kind of notation because we're working with vectors and everything. These omega naught 1, 2 are the weights, which is what we're going to try to find, these coefficients here. So it gives you two clues. It tells you that an initial boundary H is proposed, and that it passes through the point x5, and it has a discriminant value of g of x2 equals 1. So what does that mean? Let's take the first part of this, that the boundary passes through the point x5. Okay, so x5 has x1 equals 1 and x2 equals -1. So x5 equals, I'm going to use vectors for, I'm going to use the vector symbol for all of them so that I don't get them mixed up with the points. So it's 1 and -1, or it would be like around here in my little sketch here. Right? So we know that the hyperplane H, or the decision boundary, passes through that somehow. It might pass like this, or like this, whatever, we don't really know. But we will eventually. So knowing that it passes through that point is nice, but how can we, get anything useful from that? So maybe an equation or something. Ultimately, since we want to find these coefficients, we want to solve this linear system of equations. That's what the problem boils down to. So the hyperplane is described as basically g of x equals 0. When this equation equals to 0, that is the equation of the hyperplane. So if you set this equal to 0, and you made it an equation of the form of x2 equals something times x1 plus omega naught, then it will be of the form y equals mx plus b, or a line, right? So you get the equation of a line. In this case, that line is not just any ordinary line into the hyperplane, and it's the hyperplane, and it's significant because whether your sample falls on either side of the hyperplane determines how your machine classifies the sample. So we know that since g of x is equal to 0, this is true. This is true. So the hyperplane goes through x5, and that's true when x1 is equal to 1, and when x2 is equal to -1. So all I did was I subbed in the coordinates for x5 into our generic equation for a discriminant function, and I was able to get equation 1, which we will be using to solve for everything. So then the second piece of information it gives us is that it's we know that g of x2 is equal to 1. So this is like, you can pick this up more easily now that we saw how to do this one. So I should make this g of x5 and g of x2 equals 1. So I don't know why it does that sometimes. It's okay, I'll have to deal with it. So it's 2 and 2. So this is omega naught plus 2 omega 1 and plus 2 omega 2. So we have these two equations, and you can't solve an equation, you can't solve a system of 3 unknowns with 2 equations, but we can finally now use this fact that omega naught equals 1 to knock one of these out. And once you do that and you solve the system of equations, then you eventually get this solution. I'm just going to replace omega naught with 1 in case, like, you're skipping forward and you didn't hear me say that important thing. I was stuck on it for a while too, so I thought you could solve the equation, but so this becomes 1, and this also becomes 1, and that lets you solve it. So you end up with this here. So this is the, what was the question asked for again? How did they word it? So this is the discriminant function. This is the discriminant function they asked for, but this is not the hyperplane equation. They are different. So to get the hyperplane equation, you have to, as was mentioned before, you have to set g of x equal to 0. And then you can write it in terms of either x1 or x2, I believe. I usually write it in terms of x2. Please correct me if that turns out to be wrong. So then once you rearrange that, then you end up getting x2 equals negative 2 plus x1, or x1 minus 2. And then using that, you can plot a line, because it's in the form of y equals mx plus b, where b is minus 2, m is equal to 1. You can plot your line like that. If you need to translate this into a weight vector, A, your weight vector A, your boy. This takes the form omega naught, omega 1, omega 2. And for this particular case, that is 1, negative a half, and a half.